Good morning, everyone. My name is Amit Kumar Singh. Welcome to yet another session on queuing theory. So, in today's class, we'll talk about multiple channel queuing model. Already we have covered a single queue model, and in which we have discussed various applications. We have done problems related to that. 1 minute. We have done problems related to that. And basically, this queuing theory problem, either you talk about a single channel queuing model or you talk about multiple channel queuing model, there are a set of formulas which you need to aware about. And, the things are not very complex. Only few formulas are there, either related to traffic intensity or either related to waiting time in the queue or waiting time in the system, or the length of the queue or the length of the system, or the probability that you need to be wait in the system. So all that are there, not much numericals are there. So we already have covered the single channel model. Now in this class, we'll talk about multiple channel queuing model. So as you understand, like what do you mean by multiple channel? Multiple channel basically means like there are multiple servers are there who can service your required what query you have, because of which you came to a service station to resolve your query. So whenever you resolve your query for to a service system, if there a single channel is there which can understand your query and resolve it, then it is a single channel model. But if there are multiple servers are there who can talk about your query and try to solve it, then it is an example of multiple channel queuing model. And then basically in multiple channel queuing model, this is the first thing what we'll determine in the multiple channel queuing model. This is the first factor what we'll determine. So you can see this. This is called what I'm trying to determine. I'm trying to determine that the probability that there are no customer or unit in the system. So this is what I'm trying to determine. So already I have forwarded this Word document to all of you in past. So you can open this. It's all there in the group. In case if you don't have, so you can see this probability that there are no customer or unit in the system. So probability that there are no customer or unit in the system. So this would be the formula for that. So you'll determine based on this formula. Here, what is K? Here, what is K? K is the number of server. Here, what in this formula, what is lambda? Lambda is your arrival rate. Lambda is your arrival rate. Mu is your service rate. Lambda is your arrival rate. Mu is the service rate. K, what is K? K means the number of server. K basically means the number of server. So by using this formula, we determine that probability that there are no customers or unit in the system. So we determine first that probability. So once we determine that probability what you determine is called P naught. Once you determine this probability, then we'll determine the other factors. Like if I ask you what is the probability that there are n units in the system, so this is the formula for that. So if your n is less than k, so if I ask you here, so there are n units in the system. So if n is less than k, then we use this formula for that probability. And if your n is more than k, and if your n is more than or equal to k, then we use this formula to determine the probability. Then the next thing is that probability that the customer has to wait. This would be the formula for that. Again, mu is your uh, service rate, lambda is your arrival rate, p naught, this value p naught which you determined already, this value p naught that you determined already here. So you determined already here, this is the p naught which you determined already here. This is the p naught. That p naught you'll use here. So that P naught you'll use here. So the probability that a customer has to wait, this would be the formula for that part. So you can use this formula to determine the probability that the customer has to wait. Then the next thing is the average or expected number of customer in the system to determine the expected number of customer in the system. If you want to determine the expected number of customer in the system, then this is the formula what we use for that. So to determine the expected number of customer in the system, the average or expected number of customers. So we use this formula for that. Fine. As already you have these formulas, then what is the average queue length? So what would be the average queue length? So the expected number of customer in the system, the expected number of customer in the system. This is what we determine. So expected number of customer in the system. Once you determine this, then the same formula we use for this to determine the average queue length. So ls already you determined here by using this formula. Already you determined ls here. Then you determine the length of the queue. So from the ls, if you subtract lambda by mu, you will get the length of the queue. Okay, so this would be the formula for that. This would be the formula for the length of the queue. Okay. Then what is the average time an arrival spent in the system? What is the average time in arrival spent in the system? So for that, this is the formula what you can use. What is the average time in arrival spent in the system? So the waiting time in the system, you can say this is the waiting time in the system. And once you get that, then the next thing what we determine is the average waiting time of an arrival or expecting time a customer spent in the queue waiting for the service. This is the waiting time. What time you spent in the queue. This would be the formula for that. So then lambda, if you talk about utilization rate or the probability that you are busy, then this would be the formula. In case of single model, in case of single server model, so in case of single server model, that time the formula what we are using that was lambda is equal to that time when I say lambda. So that time the utilization rate that was lambda by mu. That time your utilization rate was lambda by mu. So there was only single server. So the k for that would be 1. But here you have multiple servers. So the k for that would be more than 1. So the lambda here would be, sorry, the utilization rate here would be lambda by k mu. So based on this, we're going to solve the problem. I believe already you have this Word document. So you can open this Word document to understand the formula. So based on that formula, we are going to solve the problem. Fine. So this would be the problem. This is the problem on multiple server model. So this is the problem on multiple server. This is the problem on multiple server model. So this is the problem on multiple server model. This is the problem on multiple server model. So here, if you see this question, so here the k is equal to 4. So here the you can see k is equal to 4, and then arrival average. You can see the arrival average of 100% in 10 hours. So the approximately 100 persons are coming in 10 hours. So this is every hour it means one person is coming. Sorry, every hour it means 10 persons are coming. So the lambda here is 10. Then each tax advisor spent an irregular amount of time servicing the arrival, which has to be found to follow exponential distribution. The average service time is 20 minutes. So the average service time, so the mu, so if you see the mu, so average service time is 20 minutes. So 20 minute is the service time for one person. So for 60 minutes, the service time would be 3% per hour. You can understand this. So with this, you can find the traffic intensity. So the traffic intensity would be lambda by k mu. So lambda is 10, k is 4, and mu is 3. So your lambda is equal to 10 by 12 or 5 by 6. So this you got. So the probability that the person is busy is 5 by 6 means 83.33%. And when it is free, that probability would be 16.67%. Okay, so first, what is the question is that first calculate the average number of customer in the system. So you need to understand average number of customer in the system means the length of the system. So you have to find the expected number of customer in the system. If you have to find, so first the thing which you have to determine is the probability that no customer in the system. That is what we use. So the first thing, if you remember, first thing which we need to determine is the probability. First thing we have to determine that the probability that the no customer probability that the no customer system. So the first thing we have to determine that the probability that there are no customer in the system. So that is the formula. 1 by p naught is equal to summation of maximum is k minus 1, where you start from n equal to 0, 1 by n factorial. I everyone understand now what is factorial? Lambda by mu to the power n plus 1 by k factorial. K here is 4. So 4 factorial is 24. So lambda by mu to the power k. Then 1 minus lambda by k mu. Okay, this is what we have to determine. So lambda by k mu already I have determined as 5 by 6. So 1 minus lambda by k mu would be 1 by 6. I hope you understood this. So what I'll do, so 1 by p naught is equal to, I'll start from 0. So I'll take n equal to 0 and k here is 4. So I'll go till 4 minus 1, 3. So 1 by 0 factorial into lambda by mu to the power 0 plus 1 by 1 factorial into lambda by mu to the power 1. So this I'll do till 3. So 1 by 2 factorial into lambda by mu to the power 2 plus 1 by 3 factorial into lambda by mu to the power 3. So this part is done. Then 1 by k is 4. So 1 by 4 factorial into lambda by mu to the power k. Lambda is 10, mu is 3 to the power k is 4 into 1 minus 1 by lambda by mu, that is 5 by 6. Already I have determined this. Okay. So I'll find 1 by p naught, that is equal to 1 by 0 factorial is 1. I believe everyone knows this basic. Okay. If you don't know this, so what is factorial? I believe this is basic math, factorial and all. So if I'm saying 4 factorial, if you don't know, in case if you don't know, I really believe that you know that. So in case you don't know, then I'll do that. So here, this is the problem in game theory. So in case if you don't know, so you should know 4 factorial means 4 into 3 into 2 into 1. If I say 3 factorial, 3 factorial means 3 into 2 into 1. If I say 7 factorial, 7 factorial is 7 into 6 into 5 into 4 into 3 into 2 into 1. Okay, so I guess you have understood this. So here what we need to do, 0 factor is 1 and lambda by mu to the power 0 would be 1. So this is 1 plus, so this is 1 plus 1 by 1, then lambda by mu means 10 by 3 plus 1 by 2 lambda by mu 10 by 3 whole square. 1 by 3 factorial is 6, 10 by 3 to the power cube plus this is 24 into 10 to the power 4 by 3 to the power 4. This is 1 divided by 1 by 6. So 1 by 6, 6 will go up. So this is like this. So you got 1 by p naught is equal to 1 plus, you can do this, 10 by 3 plus this is 100 by 9, 3 square 9, 9 to the 18 plus this is 1000 by 27 6. 3 cube is 27. 3 cube is 27. 27 6. So 27 6 42, 12, 162. So 162. So 27 6 162 plus this is 1 by 4. 1 by 4 into 100 into 100 divide by 81. So this is 1 by P naught equal to, you can solve this become, this is 25, this is 2500. You can use calculator and you can find this value, or if you want you can take LCM again. LCM also if you want you can do that, otherwise because here in you can use calculator, so it will be better if you use calculator and do this. Without calculator also you can do with LCM, but again it would be time consuming. 2500 divided by 81. So let me use calculator and find this value one by one each value. So one by one we can find each value. So one by one we can find each value. So 1 by P naught is equal to 1 plus 10 divided by 3. 10 divided by 3 is 3.33 plus 100 divided by 18. So this is 5.55 plus 1000 divided by 162. That is 6.1728. This is 2500 divided by 81. That is 30.864. 30.864. So 30.864 plus 6.1728 plus 5.55 plus 3.33 plus 1. So this is 46.916. So this is 1 by P naught. So this is 1 by P naught. That is 46.9169. So the value of P naught would be equal to 1 divided by 46.91699. 1 divided by 46.91699. So that is 0.0213. So the value of P naught is 0.02131. This is the value of P naught. So you have to determine this value of P naught. One by one calculation you need to do. Anyone have doubt in the calculation? This is the formula what we are using. Anyone have anything to ask? Please message here. Anything you have to ask? So this is the formula what you need to use. Anyone want to ask anything? So you do this calculation. So you got the value of P naught. P naught is 0.02131. Once you get the value of P naught, then the first question what you need to solve. Till now we have not started solving the question. We need to determine the value of P naught. So the first question is the average number of customer in the system. So if I want the average number of customer in the system, So if I want the average number of customer in the system, I find the average number of customer in the system. So the average number of customer in the system. So the average number of customer in the system, if I want to determine, so the formula, what you need to use here, the formula for average number of customer, what you need to use here, the average number of customer in the system, that is equal to the length of q plus lambda by mu. You know this. So the average number of customer in the system, so that is basically 1 by that is basically 1 by k minus 1 factorial, 1 by k minus 1 factorial into lambda by mu to the power k into into lambda into mu divide by k mu minus lambda whole square p naught plus lambda by mu. So this is the value of number of q, number of average number of people in the system. This is the formula for that. This is the formula for that. So here the k, you know, k is equal to 4. So you know that k is equal to 4. So k minus 1 means 3. K minus 1 is 3. 1 by 3 factorial. The lambda is 10. This is 3 to the power 4. Lambda is 10 into 3. This is k is 4 into 3 minus lambda whole square. P naught. P naught is how much? P naught is 0.022131. This is 0.02131 plus lambda. Lambda is 10, mu is 3. So you can do that. So the length of system is equal to 1 by 6 into 1 by 6 into this is 10,000 divided by 81 into 30 divided by 2 square means 4. This is 0.02131 plus 10 by 3. So you can solve this. So this is 5 this is 5 then this is 2500. So the length of system is equal to 12500 divided by 12500 divided by 81 into 0.02131 plus 10 by 3. You can solve this value. So 10 by 3 is 3.33. So I can use calculator and I can find this value. So that is 12500 into 0.02131. That is 266.375. This is 266.375 divide by 81. So you get 3.288. This is 3.288 plus if I add on this. So if I add 3.33 on this, you get 6.6184. You got 6.6184. This is the length of the system. The length of the system 6.6184 or 85. This is the length of system. So average number of people who are waiting in the system is 6.6185. So you can say approximately 7. So if you want people, because number of people cannot be like this, this you can say equal to 7. So approximately 7 people are waiting in this system. So that is the question. The next question, average number of customers waiting to be service. So So average numbers is customer waiting to be serviced. So average number of customer waiting to be serviced means you have to find this value. So you have to find this value, this value. This is the value. This average number of customer waiting to be serviced. This value you have to determine. This value you have to determine, and that is this. So which you already found here. That is the number of customer who are waiting to be serviced. So that you have to determine. I should logically they should ask this first, then they should ask the average number of customer in the system. So this is if you like I added no 3.33. So if I subtract 3.33 from this, so I get 3 point some answer. So so you understand, So the next question, average number of people who are waiting in the system, average number of people who are waiting in the system, average number of people who are waiting in the system. So the average number of people who are waiting in the system. So that is already we have determined that part. So that part, the actual formula for that already I have written down, but again I'm just simply writing it down. So that is 1 by k minus 1 factorial, which already we have found. Then 1 by k minus 1 factorial into lambda by mu to the power k, lambda by mu to the power k into lambda into mu divide by k mu minus lambda whole square into p naught. So with this, I will find the weight average weighting in the queue, and that you already found here. So the sum total of this was 6.6185. This is nothing but 6.6185. From this, if you subtract 3.33 of 3 of 10 divided by 3, so most probably we can get a fair picture. So the answer would be around 3.2, 3.28, or you approximately you can say as 3, because number of people cannot be in decimal. So approximately you can say 3 customers are waiting in the queue. So I hope you understanding this. So because the number of person cannot be in decimals and all, so that's why I've written like this. Then the third question. Third question, average number of person waiting to be serviced. Average number of person waiting to be serviced. Average number of person waiting to be serviced, that we determined already. So average number of customer in the system, average number of customer waiting to service, we found. Then next thing is average time a customer spent in the system. This is waiting time in the system. Average time a customer spent in the system. So average time, the average waiting time for customer. So that is WQ. Average waiting time for a customer, that is WQ. So average waiting time in the system, that is WQ. So if you want to determine this, so if you want to determine the next question, that the average waiting time, first I'll determine average waiting time a customer spent in the queue, then I'll find the system. Okay, first I'll find the queue. So average waiting time, average waiting time a customer spent in the system, average waiting time a customer spent on a system, average waiting time a customer spent on the system. So that is equal to the WQ. The average waiting time a customer spent on the system, that is WQ. So the WQ is equal to the length of queue divided by the lambda. So the average waiting time a customer spent on the system, that is equal to the length of queue divided by the lambda. Lambda here is 10, and the length of queue. The length of the queue already you found, that is around around 3.2885. So the length of queue is 3.2885, 3.2885, and the lambda here is 10. So your answer is 0.32885. So here you're talking in the term of hour, right? Here you're talking in the term of hour. So if you want, you can convert this in minute or second, anything. So you can convert this into minute if you want the answer in minute. But if you remember, we are solving everything in the term of hour. So lambda and mu, everything we took in the term of hour. So here the average waiting time for a customer in the queue, or the average waiting time of the customer in the system, everything we determine in the term of hours. So unit, again, I'm telling you, using units are altogether it's something which is very important, and we really need to work on that part. So then the average time a customer spent in the system. Once you found the WQ, average time customer spent in the queue, once you found out that, then the next thing we need to determine is the average time a customer spent in the system. Then the next thing we have to determine is the average time a customer spent in the system. Average time a customer spent in the system. Average time a customer spent in the system. Now that we have to determine. So waiting time for the system is waiting time. So the waiting time for the system, waiting time for the system is waiting time for the queue plus 1 by mu, plus 1 by mu. So waiting time for the system is WQ plus 1 by mu. So WQ already you found 0.32885 divided by 1 plus mu. Mu basically means what? Mu is 10. The how many customers are getting service. Lambda means arrival. Mu means the service. So waiting time in the system. So WQ is 0.32885 plus 1 by lambda plus 1 by mu. Mu here is 3. So, so we can find the average time customer spent in the system. So we can find the average time a customer spent in the system. So this plus 1 by 3 point plus 1 by 3. So 1 by 3 is 0.333. If you add 0.333 in this, if you add 0.333 on this, then probably you get the value as 0.6561, as the that is equal to 0.6561. So you can get that value. That is nothing but 0.32885. On this I add 0.33. This is 885. Then this is 5 and this is 6. This somewhat it will come like this. So that doesn't matter much on the answer. So this is the average waiting time for the customer in the system. So waiting time also will determine two things: waiting time in the queue and waiting time in the system. So like the same way how we determine the length of the queue. So that again depends on the similar factors. Anyone have any doubt? Anyone want to ask anything? Anyone want to ask anything? So we determined the waiting time in the system. We determined waiting time in the queue. We determined the length of the queue. We determined the length of the system. So all these factors we have determined already. Then after that, what you have to determine? After this, I think all this I have determined. Now the next thing, average waiting time for customer. This customer we did, and probability that the customer has to wait before he get the service. So the probability, if I talk about probability, if I talk about probability that the probability that the customer probability that the customer waits for its service. So the probability that the customer waits for the service in the queue. So the probability that the customer wait for service in the queue. So that probability here n is greater than or equal to. So probability part we studied two formula. So if n is greater than k or n is less than or equal to k. So here the formula is 1 by k factorial, 1 by k factorial into lambda by mu to the power k into 1 divided by 1 minus lambda by k into mu into p naught. So this is something which you have to determine. This is the probability that the customer has to wait for a service in the queue. Okay, this is what you have to determine. So k here is 4, you know that. So this probability what you need to determine, that is 1 by 4 factorial is 24, lambda is 10, this is 3 to the power 4, this 1 divided by 1 minus k is 10, this is 3 into 4, this is p naught. P naught value, what is the p naught value? P naught value already you determined in the beginning. So the p naught value what we determined in the beginning, it was 0.021 something. 0.02131. So this is 0.02131. This is 1 by 4, 24 to 10,000 divided by 81. This is 1 minus 1 by 10 by 12 is 5 by 6. So 1 minus 5 by 6. So this is 1 minus 10 by 12 into 0.021. This is 0.02131. This is 0.021. 0.021. That I'm writing till only 3 digits. So this I can write as 5,000. This is 12. Then this is equal to 2500. Then this is 6. So this is 2500. This is 2500 divided by 6 8s are 48. So this is 2 divided by 12. 2 divided by 12. So 1 by 2 divided by 12 means 1 by 6 into 0.02131. Now you can solve this. This is 3s. This is 243. Now you can use calculator and you can find this value. Everyone use calculator and find this value. Two five zero into 0.031. 0.021. divide by 243.2192. So the answer what you will get is 0.2192. Hmm. Anyone want to ask anything? This is anyone want to ask anything? Anyone want to ask anything? So so this led to the end of the course, and from tomorrow we'll do revision. From the first chapter we'll do revision for you. So I have finished your portion. I have finished your portion. So from tomorrow we'll do revision. Anyone want to ask anything? Clear? Anyone want to ask anything? Any doubt, anyone? So from tomorrow we'll do revision for you. Do you want finance classes? Numerical finance, numerical classes? So like no one is replying. So I guess now like you people don't want finance numerical classes. No problem. So that's okay. We'll focus on operation research only, because from my end your portion is over. Now from my end your portion is over about operation research. So so now I want to take revision for you people for the exam preparation. So if you want to ask anything, please tell me. Anyone want to ask anything? So guys, I believe that you have understood what all we have covered till now in operation research. Any question, anyone, any college, any internal exam question paper, if you have, you want that to discuss, we'll do it. We'll do it in our revision classes. So fine. So with that, then I'll end the class. If nobody have anything to ask, I'm guessing that you people have understood everything and you don't have anything, any concern to be asked on that. With that intention, I like to say goodbye to everyone. Hmm. Here I missed one thing. This is okay. This I could have done here like this. This I'm writing 243 means this should be 3. This should be 3. So probability here this should be 1 by 81. I'm writing 2500 into 0.02131 divided by 81. So this will come around 0.658, around 0.65 something. You can ignore this answer. Fine. So anyone, anything to ask before I wind up the class? Anything you want to ask? Okay, guys. So I believe you have understood what all we have covered in this class. So with that intention, I like to say goodbye to all of you. Thank you, everyone. God bless you. See you, everyone, tomorrow for the revision classes. Thank you, everyone.